shared profile info or user info or something else that you could use to get that. And right, like, so you're right, here's my audience. He's taking the question. So, okay, so we're going to somehow figure out whether or not that's something that is part of the adjacent to cloud, or whether or not we're probably that one reference to the user building. That's a question, or the other question. That's what I think.
Yeah, it's always just like, he's like, you got it. Yeah. I was like, well,
why is this? Why
yeah. Oh, okay, with email. So, yeah, so I sent this will actually be a quick way to sort of yeah. Yeah, it's like it works pretty well. All right.
Did not realize that.
Oh, I see.
There was a like legitimate camera for like the first like 2 weeks, and then something happened to the box and it doesn't work anymore. So we just didn't get back again on the last. Yeah, not the greatest resolution, but you know what? Better than nothing. Better than nothing. So usually Alex starts within 2 or 3 minutes. Like he will let it go a minute or two, but not much.
I just don't know what to expect.
This is like middling. It's like another 2 minutes. Nothing forever. The involvement is like I think at this point about that we have about 6 Again, you had like 3 more people walk in and people talking, which gets you up to the
Okay, let's go ahead and get started. So I like to start my classes by asking if anyone has any questions. Usually that pertains to this class or like, you know, the material that we covered last time or the assignment that's due next week. So if you do have any of those questions, I would say ask them and Sam can hopefully help. I don't think I can. But I'd be happy for you to do that if you have anything that you kind of need to start with. Okay, so you should all have, maybe not all, a lot of you should have at least one question, which is, who am I and why am I talking at you? Right. Okay, so my name is Jason Weezy. Say it Weezy. This is a little bit about me. I started here at Utah as an assistant professor in 2016. So I've been here a little over 2 years now. I got my PhD in human-computer interaction at Carnegie Mellon. I'm a Utahan now. I love it here. Can't wait for an epic ski season. Yeah. So what I want to do today is cover a couple of different things. So my understanding, right, is that this is a Viz course. You've got some human-centered components, but being human-centered is not the sole focus of what you're doing in the course. And since I happen to be the track director of the Human-Centered Computing graduate degree, or graduate track in computing, whoa, what is going on here? I feel like there's some problems with timing. It should not be advancing on its own. Use comics, do not. Okay, great. Okay, so I want to give sort of a high-level overview of human-centered computing, what I think it is, and human-centered computing research, which is what I do when I'm not teaching classes and mentoring students. Sometimes I'm doing it when I'm mentoring students. And then I want to go more specifically into the research that I do, which is all centered around personal data in different ways. And then I want to bring it back to what you're actually talking about in this class, what the subject is, which is Viz. So this is not a lecture on Viz, but I still think that it has some important implications, or at least applications for visualization. Right. So what is human-centered computing? I'm not going to ask you to answer that, but I'm going to say that I think that there are lots of examples of making technology when we don't think about humans first and foremost, right? So I love this example. I've nearly done this for my in-laws multiple times, right? The questions that I get, it's incredible, right? And it's because if you think about the TV watching experience, right, that TV guide that doesn't give you any way of knowing that local channels start at 884, right? This is an absolutely terrible design. And so we make hacks to go around the implementations that people give us because people weren't thought about. How people are going to use technology wasn't thought about from the beginning. Right, so the elevator button example, I've got to guess at which one goes up and which one goes down. And that is entirely based on the fact that the arrow points to the button, and that's the only thing that I have to go on here, right? It would be totally reasonable for you to say the one that's next to the arrow next to the button is the one that indicates where that one goes. Boston, right? Okay, so yeah, right? We should think about people when we make stuff. That's human-centered computing in a nutshell. You're done. Right, so the idea behind human-centered computing research is that we design, build, and study new tools and technologies that can support human activity or existing technologies, right? So part of this is thinking about how are people using technology today? What is their experience? What is the impact of technology on humans? And part of it is saying, what would we make, or how do we make things, and how should we make things differently at sort of a meta level, right? So it's thinking about sort of the structure of the creating of things, right, and how that might be different in the future. There is so much work happening in human-centered computing. Just to give you an idea, the CHI conference, which is sort of the top conference for HCI, HCC style research, has somewhere around 3,500 to 4,000 attendees a year. This is an academic conference that's bigger than almost any other conference that ACM runs. So, and there are 16 parallel tracks happening at the same time, right? So all different types of technical sessions, and things like range, like you name it, if it has something even remotely to do with technology, probably there's something there that's related to that topic in some way, right? So one of the crazier things I saw was someone talking about their experience of designing their own like camper van, like hashtag van life, right? So this was like a person describing their experience designing their own space and then drawing some lessons from that that we can use when we're thinking about design, right, and sort of personal design. Okay, so stop me if you've heard this before, right? We use a bunch of different methods. So not only is it really broad in terms of the domains that human-centered computing covers, but it's also really broad in the tools and techniques that we apply, right? So interviews and surveys, sort of more from a psychology perspective or a psychology background. These are sort of key. If you talk to any of my students that I work with, this is the very first thing that we go to is, what do we know about the target population? And if we don't know enough, then we have to find out more. So we make hardware and software prototypes, we deploy them, do data collection, experiments and stats, and of course everyone applies machine learning to everything, and so we do too, right? And so I mentioned the human-centered computing grad track. If you're interested or curious, how many people in here are in that track? Okay, so a couple. And how many are interested and maybe thinking about it? See a couple, cool. Right, so I'm the right person to talk to. I'm the track director. We put this track together trying to give you an avenue to explore human-centered computing very broadly, and giving you sort of a strong base within the School of Computing from which to do that. Happy to talk with any of you about that more, right? So there are those 4 core classes. This is one of them. And then there are 6 electives. You can take 3 from other departments. And we've had some really great experiences just in the first year and a couple months that this has been available. Right, so there are a lot of us working in human-centered computing. Why human-centered computing and not HCI? So you see both of these terms sort of thrown around a lot. HCI, human-computer interaction, is often used in a very specific way to refer to a specific type of people with a specific set of training. So that's like, my PhD is in human-computer interaction. That's fine. But there are lots of us here who maybe don't have direct training in human-computer interaction who are still doing things that are human-centered. And so human-centered computing is our term that we use here, and it's also used at various institutions around the country to sort of incorporate this broader perspective that humans are at the center of the work that we're doing. So we've got a bunch of stuff going on, and that's all I'm going to say about that, because really what I want to talk to you about is my own research, which is basically what anybody wants to do. If you're tenure track faculty, right, and you can't get somebody's attention because they're teaching your class and it feels like they're too busy, like ask them about their research and see how quickly that changes. Okay, so my research is all about personal data. Why? What are we even talking about with personal data? Okay, so I have a hypothesis, and that is that we are not in the middle, we're not at the end, but we're right at the beginning of sort of an exciting new wave of super personalized user experiences, right? So Nest has been around now for a couple of years. The idea, right, is that you set your thermostat at home over time after you've set it in different conditions, under different circumstances. It learns something about you, it can infer that about you, and then hopefully it starts to make those changes on its own without you having to set it, right? And so it's this sort of personalized thing, it learns from what you're doing. Right, so Siri, the Google Assistant, Alexa, there's this idea, right, that we can use the data that exists in these services in, Amazon or Apple or Google services to get us information a lot faster, the information that we specifically want. My information is different from your information, right? So these are pretty cool. This is roughly the forefront of personalized technology today. But my hypothesis is that this is really just the beginning, and that even now, if you squint your eyes a little bit, you can start to see what that future out there looks like in front of you. And so for one example, if you saw, did anybody see the movie Her? Yeah, this looks kind of familiar. Okay, so for anyone who didn't see it, this right here is sort of like Siri, Google Assistant, Alexa on super duper steroids, right? This thing knows everything about the main character Joaquin Phoenix plays, right? This like maybe knows him better than he knows himself. Now we can argue for a while about whether that's a good thing or a bad thing, and I'm not saying that it's a good thing necessarily, but you can imagine that, you know, this is far away from what the potential future could be, and then just have a little bit of trust in humanity, and you might find that hard to do, that we're not going to do the wrong thing with that. Okay, so that's one example. What do we have next? So Spock in a Vulcan learning pod. So this is a very sort of quick example in the movie, but the idea behind these learning pods is pretty cool, right? So it's leveraging his own experience in the world, in his education, right? So it's not just saying, here's, you know, some equations that you need to learn, even though that's what it looks like here, but it's actually leveraging things that he has done in the world as it's teaching him, right? So this is hyper-personalized education. Okay, I didn't have a good movie reference for this. If anybody can come up with one, please email me, right? But healthcare is such an important thing, and there are so many advances to be made from a personalized perspective that it would be ridiculous not to mention the potential for hyper-personalized healthcare opportunities that exist on the horizon. Okay, so we have all of these three domains. I'm going to say that I think that there are more, but these are three, you know, pretty accessible examples: personalized healthcare, personal assistance, personalized learning. The thing that brings them all together, you guessed it because I told you what I'm talking about now, is personal data, right? And the thing is, we are generating a huge amount of personal data, right? So basically, any service that you touch, even if you are not accessing it electronically, even if it's a face-to-face interaction, you are generating some sort of a digital trace, right? That's capturing your interactions with other people, your interactions with services. If you think about commerce, education, entertainment, communication, all of these are mediated by technology for many people, at least in the US today. Let's say first world countries. And of course, we've seen an influx of data from smartphones, from wearables, from instrumented environments, smart homes, right? So this data is everywhere. It's coming from basically all aspects of our lives. And so the idea here is that data is going to fuel this really, you might say exciting, you might say terrifying future of personalized computing, right? And the problem is that is kind of really hard if you think about how we're going to get there, right? So we've got all of this over here sort of spread out. I don't have any control over this. Some magic happens, and then we have that awesome future. Watch, like 5 years from now, it's always, everything's like 10 years from now, right? Like autonomous driving has been 10 years from now for like the last 8 years, maybe longer. Okay, what is the issue? I think there are actually lots of issues, and it's not so simple, and some stick figures that I threw together in PowerPoint aren't going to totally illustrate it, but it's going to give you a sense, right? So this is probably not surprising. This is the way that data is stored today. Every company has its own sort of data silo. You can think of it as a silo or a database or whatever you want, but you know, Amazon can use my data and your data and everyone else's data and do awesome data science and data analytics and try and figure out how to sell us more stuff. So this works really well for that, but it doesn't work for that personalized future. Right, so what we need for that sort of hyper-personalized future is to have data that's organized by me, right? So I can't today look at all of my data in one place and see the sort of interesting interconnections. And the sort of underlying hypothesis that I have is that if you take that data and put it together, then you are going to see things that are very interesting, you know, can talk about privacy for quite a long time and sort of the concerns of who it is that owns and controls that. But even just from a technical standpoint, we're very far away from having all of that data brought together in one place. And, so why is that? Why don't I just go and build that system that brings all of this stuff together and have that future? Why? Anybody have an idea why I haven't done that already, or any thoughts? Yeah.
Everybody stores it in kind of different formats and totally different ways of treating their data.
Yeah, right. So this sort of mismatch of schemas and like trying to bring all of that together, absolutely, that's one thing.
There's a whole concept of who actually owns the data.
Right. What does ownership even mean when it's something that you can copy just as easily as, clicking a button, right? Like I can own this laptop because I can't easily recreate one and hand it to you and still have mine. Yeah, so ownership, definitely. There's another reason, that's one in particular. So even if I don't own the data, it's about me, so maybe I can still do something with it. Any other ideas? Yeah.
There's the companies that are collecting it. I mean, that's how they make their money. They're not going to give that away for free.
Absolutely, right? So this is the core sort of business model of these companies. Apple, we'll say, is sort of not included in that directly. They've got other business models, you pay them directly. Amazon, yeah, of course, you pay them directly, but also they make a lot of their money based on the data that they've collected about you and knowing how to optimize their sales. Facebook certainly makes money off of you. Google makes money off of your data, sort of brought all together. I'm not saying that that's wrong or that they're inherently evil for doing that. That's a conversation, again, we could have a little bit later. But whatever the case, this is core to their business model. The company is not going to voluntarily just give you free range to do whatever you want with that data, because that's going to undermine the business. And that's not the society we live in, that a company is going to do something that's going to actively undermine what they do as a company. Right? And so another way of thinking about that is that the data that you want to get access to, right, it's not easy to get access to that. So forget about who owns it, who has the right to delete or preserve or anything else. You can't even get programmatic access to that data. Right, so the good news is things are changing. Right, so GDPR, you should have all at least heard of when you deleted about 800 emails back in May, right? There were all of these, we're using cookies to better serve you. We've updated our privacy policy. Don't hate us, right? That was I think I got it right.
Yeah.
So GDPR is an EU data protection regulation. It's got all six are very important aspects of the GDPR regulation. And the interesting thing is that because the EU is so big, right, when they do this, and also because it's hard to know exactly who lives where and who exactly this applies to, this actually impacts the entire globe, right? Everyone who has data in any of these services, it's easier to just do it for everyone than to try and figure out how are you going to slice and dice your customers so that the EU people these things apply to and the US doesn't apply to, right? And so this is great. One thing in particular that's really nice here is this data portability regulation. So what the data portability regulation says is that you have to have access, downloadable access to any data that is stored in any of these services if it corresponds to something that you've done. If it can be identified as personal data and they've got a formal legal definition, then you have to be able to download and see what that data is. That's super duper awesome, right? So we're like one smaller step closer. It's not programmatic access, right? You have to do this on your own as an individual consumer, but you can download your data, you could import it into some system, and you could do things with it. If you go to your account.google.com now, Google actually has had good services for this for a while called Takeout. You can download any data that Google has about you. Now, Do I know that they absolutely don't have any other data about you? No, I don't know that, and probably they do in some way. But it's still really super awesome that you can download basically any of this data that they have about you. So that's cool. So we're solved. We're like done. We can go home. Obviously not, because class isn't over yet. Right. So the question is, okay, even if you can collect the personal data and get programmatic access to it, thanks GDPR, what do you do in the middle, right? So there's still this question of like, you know, what do you do once you get all of that stuff? Right. So I'm going to talk you through sort of my high-level research vision, a couple of specific projects that I've worked on within this vision, and then kind of open it up to some Viz questions again at the end. So, conceptual framework for personal data. So I'm going to use this framework to help illustrate some of the reasons that this is still hard and sort of try and unpack why there's still interesting work to do here. So this framework is a continuum. The idea is that all personal data you can think about, you know, at least conceptually, being on somewhere on this continuum. So it goes from really low-level data on the far left to really high-level data on the far right. I understand this means nothing to you right now. I'm going to give you examples. Okay, so something that is, I would argue, a piece of personal data that is at a really high level is this question: am I becoming depressed? Right? And this is a really important question, right? People don't necessarily realize that they're becoming depressed, and they don't realize that they should be seeking out help or support. And so this is a question that if you could infer automatically could be really impactful for the world. Right, so that's a really high-level question, and that's not something that I believe most services can really provide to you today, at least not directly. But I think if you step down this continuum, you can start to see sort of how we might be able to get there. Right, so below this holistic understanding example are a whole bunch of personal inferences. So they're at a little bit of a lower level, and these are things like, you know, I've been less social, or I've been doing fewer things that I enjoy, haven't been sleeping well, less physically active, significant changes in weight, pretty stressed, right? So these are sorts of things that are still pretty high level, right? They describe me at sort of a conversational level. These are things that physicians use to diagnose depression, right? And so you could imagine that if you took this data in the right way, and if you could trust it, that you can see how this might tie up to that holistic understanding of, am I becoming depressed? Right, so this is still pretty high level. Most of these things a computer can't observe exactly directly, right? You can observe them through sort of a set of lower level pieces of data that come from many of the different services that I described a couple of slides ago. Right, so the idea here, these are discrete sorts of events, things like your communication behavior, things like, you know, if you have a Fitbit and you collect sleep data or physical activity, if you have location history, right? So music listening logs, right? You could infer a lot of those inferences that I just showed on the screen from this data, right? That is all pretty easily collectible from the services and devices that we have today, that we use today, right? So again, what's the challenge? The challenge is that maybe I don't just use one email account. And so depending on what email account some developer uses to make this inference, they might say, Jason's not using his email at all. He's definitely depressed. No, I just have 3 email accounts and you've only connected to one of them, right? So that's sort of underlying what this big problem is. Right, and then for some set of these things, it's a little bit misleading, right? We actually have to kind of go another level lower to think about sort of raw, low-level streams of data. Right, so these are the sorts of things that are probably not human readable, not interpretable on their own, right? Like you wouldn't know if I told you that said that I just ran a marathon, or if that said that I've been sitting, not moving at my desk, right? You could probably infer some things if you thought about the X, Y, and Z, but you know it's not going to tell you very much. right? But we have all of these streams coming from sensors and all sorts of different things that we can instrument in the world. Okay, so now that I've gone sort of from top to bottom, I want to loop back to the top and just say, I don't think am I becoming depressed is the only question that we can answer here. I'm totally interested if other people have ideas about the sorts of questions that we might be able to ask at this high level. But I threw up some here that I think are potentially interesting, right? So thinking about, we're about to do a huge faculty recruiting year again, right? So who's the best match to our faculty across a bunch of different attributes? Some of them might be research-based, some of them might be teaching-based, other sort of social or other factors that would indicate that they'd be a good match. What should I be when I grow up, right? Like maybe if I had this tool, then I wouldn't be up here standing in front of you right now. I'd be doing the thing that I was actually meant to be doing, right? We don't know. I think it worked out okay. Right, so how can I live more sustainably? Whatever. You can see the list there. I think that there are these other sort of high-level questions that could be really useful to us living our lives, and that the data could help us to answer for ourselves. Okay, so we've got this continuum. The next idea that I want to talk about is that there's a common process for working with personal data that you can sort of think about when you're looking at this continuum. And so the idea is that somehow or another you're going to collect the data. It comes in from somewhere, whether that's something that you control or a third party. That you're going to infer meaning, so there's sort of a general assumption that we're taking data and we're moving it up the continuum. And then that we're ultimately going to use it for something. So it doesn't do us any good to just have an inference, we actually have to apply it to some context. And so, this might look pretty simple, but I don't think it is. And so I want to give you some examples to help you understand why. Right, so even if you're doing this today, even if you can get the data from different APIs and services that you have access to, you have to connect and authenticate to all of those different APIs yourself individually as a developer if you want to build some service that's going to depend on these things. Everybody has their own sort of mechanisms for doing this, their own schemas, right? So that's step like 1A. You can't do anything else beyond that. Often, if you're going to make inferences, you have to also be collecting real-world ground truth from the users. And I'll show you some examples a little bit later of how data that you collect and data that I collect still have individual meaning and can't necessarily be interpreted the same way. You have to think about how you're going to store the data securely, and also just for efficiency and other sorts of performance aspects, right? You have to think about how you're going to link this data together. This data wasn't necessarily meant to be linked together. It came from these different sources. They weren't thinking about how are these things going to integrate with things that aren't within our sort of web of services. This is why when companies merge, you see like maybe 2 or 3 years go by before they start to have products that are actually integrated across them, right? These sort of deep-seated schema issues sound super duper boring, and they are, but they're also really important and pretty hard. Merging duplicates, I've got to tell you, I tried to do this for one of my studies, and as easy as it sounds, it is absolutely terrible. Okay, that was step 1, right? Now we're on to step 2. You have to know what it is that you want to infer. Again, that sounds trivial. Well, of course you know, it's your application, it's your system, but do you really know exactly what it is that you want to infer and all of the potential classes that you could be inferring? You have to know how to apply the machine learning correctly. Fairy dust and it's done, right? And you have to develop the features from the source data in order to actually be able to do that machine learning. And then, of course, even using the data has many different aspects to it. So you need to be thinking about applying the inference, handling incorrect inferences, right? So does that go back into some sort of central thing? Do you remember those? Do you retrain your model? You need to be thinking about protecting people's privacy and giving them adequate control over their data, and all of this, now combined in potentially more sensitive data. Right, so this is a crazy process to expect an application developer to go through on their own, right? This is why we don't see these really interesting integrated personal data applications coming from third-party developers, because there's no way that I'm going to do this unless I know that I'm going to make $1 million off the bat, right? Like, how are you going to spend all of the resources to do this unless you know that that personalization is going to give you a massive return on your investment? Okay, so now that I've introduced that, that process, I'm going to switch gears a little bit and talk about some projects that I've worked on different sort of pieces of this continuum, just to give you an idea of what that looks like in the research world. And then I'm going to come back to the continuum and this process again in a little bit. Okay, so this first work is work that I did when I was still a PhD student. I was an intern at Microsoft Research. So this was a summer project for me. And so the idea here, does anybody know what the word proprioception means? Somebody want to just shout it out?
It's how you, for your hand, you know where your hand is in space.
Yeah.
Proprioception of your hand.
Yeah, exactly right. So if I close my eyes, I know that my hands are on my side right now, I know that they're out here right now, I know that they're about to touch, right? Because I don't have to look at them to know that, that's my sense of proprioception. So phone proprioception is a play on words here. The idea is that the phone will have the capability of knowing where it was placed, right? It's not a direct one-to-one mapping, but I still thought it was clever, so that's what we did. Right, so why should we infer phone placement? So one situation that might be useful is to know information for dynamically adjusting phone notification preferences. So we've all been in like a meeting or a class where someone in the audience phone starts ringing and it's super disrupting. Everyone's embarrassed. You'd rather that doesn't happen. That was one of my co-authors. I graciously participated in that video. And so the idea here is that if the phone knew that it was out on the table, then it could just flash the light on the flash rather than, make this terrible ringing noise, right? It doesn't even have to know that you're in a meeting. It just has to know that it's out on the table and then it might be visible. Okay, so you can imagine other situations where this might be useful. Honestly, pocket dialing somehow still happens in this day and age. I get, again, not to throw my in-laws under the bus, but I get these random calls from my mother-in-law, and it's just like, oh, I guess you're like out for a run right now, or like, I don't know. Yeah, somehow pocket dialing is still a thing. Right, so dynamic authentication. So actually what's really cool is we did this work back in 2012. It was published in 2013. Since then, right, so in the 6 years since we did this work, these ideas have actually been incorporated in a bunch of different places, including the now deceased Windows Phone, and in some of Android. I actually don't know about iOS, but I imagine that some of these things are probably also there too. They were not at the time, right? So something like, you can say when I'm at home, then you shouldn't prompt me for my password, but when I'm at some place that I've never visited for, then you should prompt me for my fingerprint and my password, right? Like when it's been sitting out on like a table, right, you can infer that maybe somebody else could have picked it up, or if it's been on my pocket the whole time, then, maybe you know that you don't have to ask for my password again. That's the actual example that was there. Okay. So in this project, the high-level goal was to sort of use the sensors on the phone so that it could infer where it was being kept. So broke this down into several steps that sort of gives you the idea of what a human-centered research process looks like. So the first thing I did was interview 93 people and send out surveys on Mechanical Turk to another 600 people to get some responses about where they put their phones when they're in different situations. Right, so why am I doing this? Because I'm a very particular individual. At that time, I'm a graduate student. I live, and die by my phone even in 2012. I'm a white man. I always have pockets on my pants. There are all sorts of reasons that my perspective on where phones are placed is not necessarily the right perspective or the only perspective, right? And so the idea is we need to go a little bit broader than just the experience of me in order to figure out where do people actually keep their phones in the real world. Right. So I'll spare you the details of all the analysis we did. It is in the paper if you're curious. Basically, it comes out to roughly what you'd expect. And then within these, there are a bunch of subcategories that sort of come down below them. So basically, most of the time, people keep their phones in a place like their pocket, their bag, out, or in their hand. Right? And so that sort of matches intuitively what you might think, at least retrospectively. But you'd be surprised at how many people don't fit all of those categories on a regular basis, right? So it's not true that everyone does that. We also got some interesting responses, like I think one participant told me that she keeps her phone in her bra, which is fine. Like, there's no value judgment there. It just never would have occurred to me that that's a place you could put a phone. Like, I just wouldn't have known it, right? Okay, so the idea here was that we were going to use this information to help us decide the class values for the inference, for taking these sensors and inferring where the phone had been placed. Right, and just a thing about the survey. So I did these interviews in part by going around Microsoft and ambushing people basically while they're sitting in their office and say, hey, where's your phone right now? And then like, oh yeah, by the way, I'm an intern and I'm doing a study and please don't call security. And the idea was I wanted to get as authentic of a thing as possible. If I set up an interview with someone and told them I was studying phone placement, who knows where their phone's going to be, right? So the idea was to try and get as authentic of a response as possible. But then we said, okay, even if we interview these people around Microsoft, what does that tell us about the world? And so we took some of what we learned from the interviews. We asked people, where they keep them in different situations, and put it into a survey that would be a little bit easier for people more broadly to fill out without me conducting an interview with each of them, right? And so then we ran a Mechanical Turk. We got a much more diverse sample, and we sort of, it wasn't just confirmation, but mostly we got confirmation that the things that we learned about were roughly correct. Okay, so that was step one. Step two, I developed this Windows Phone, when it still existed, app. And the idea here was that I wanted to collect a bunch of labeled data, right? And so what do you need if you're going to collect labeled data about phone placement? You need the sensor values that capture what the sensor reading is when it's in a particular place, but then you also need the label. And you don't want to ask somebody, hey, label this thing that I'm about to record right now, because then they've got it in their hand. You're only ever going to get in hand as your answer for where people put their phones, right? So instead what we did was we would wake up the phone, collect a little window of data, and then pop up with a notification afterwards that said, hey, where was the phone at 4:29 p.m.? Right, and give them like a 30-minute window basically where they could label it, and then at some point you say, well, we don't think that data is going to be as accurate, and so we're just going to forget about this and dismiss that. Right, or there's always the I don't know, which also has the same response there. So the idea here was that this pops up, it's really quick to hit one of these buttons. This was actually a two-level labeling process, so if you hit bag or if you hit pocket, then it would say front pocket or back pocket, or right, it would give you a couple of different options there. So we ran this, and again, so we ran this in the wild, and that's because where people are going to put their phones, if we say, hey, come in for a lab study and just put your phone where you normally put it, in this like weird room that you've never been in before, right? Like nobody's going to do that, or it doesn't accurately represent what they do in the real world. So we actually deployed this in the real world and had people collect data as they go about their lives. Okay, so took the accelerometer data, did some machine learning magic with it, right? Calculated a bunch of features, used 1-second windows, leave one person out cross-validation so that we don't train models based on the same people that we're testing. Yeah, it's not a machine learning class, so I'm going to sort of gloss over that for you. Okay, so the results. So we've got these pretty good for in the wild, like first go, non-optimized results. So what we did is we folded those 4 classes that I gave you before, in bag, pocket, out, or in hand, into a couple of binary classes. So you can imagine enclosed or out. Enclosed would be in a pocket or in bag, and out would be out or in hand. So that was one class, or one model that we trained. The reason that we did this is because a 4-class classifier is inherently going to be less accurate than a binary classifier. So we wanted to see, hey, what are the different accuracies we could get if we were trying to answer different questions for a particular application. So these are fine. They're not excellent, and so the next question is, what could we do to make them more excellent? So the answer is, hey, let's maybe add some sensors. But it's hard for me as a researcher to manufacture a new phone that adds sensors that I can have programmatic access to, right? And so instead, we now moved over to a lab study and added some sensors. So this is a capacitive sensor. It's basically what's on your phone's touch screen, but it's just the touch sensor part of it, and it's not the screen part of it. Turns out that's actually very low power compared to running a display. The problem is that you can't get access to the raw capacitance when it's on a phone, and so you can't actually, that's all optimized in hardware, and so you just get touch points when you get the signal coming from the screen, and so that's why we had to sort of roll our own here. This is an Arduino board that I rigged up with a couple of lights, LEDs, that would illuminate a surface, and then a couple of sensors, photodiode, and a light to frequency converter that are looking for what the reflection is of that light after it illuminates the surface that it's against, since the idea is maybe knowing the type of surface that it's against will tell us something about what's going on. And then again, the proximity and light sensors. So that seems like sort of an obvious thing. We should have done that from the beginning, right? Sadly, I was at Microsoft Research, right? This is Windows Phone. Windows Phone did not give you access to these things. Running that first study on a not Windows Phone was not an option, and so this somehow became part of our lab study. It worked fine in the lab study. So, okay, so the setup was we had people put each of those 3 devices in each place. So their front pocket, their back pocket, jacket pocket, bag, and hand. And then we had them try to simulate normal activities, right? Fully acknowledging that this is a lab study and this isn't a real in the wild thing, but we want to simulate what doing some real activities would look like. Fun little thing was that the capacitive sensor had to be connected to a computer, so I'm like chasing them around with a laptop as they're like walking around this like conference room. I think it was still like a pretty good simulation, not excellent. So, right, and then putting it up against surfaces. So the variation in surfaces is not based on individuals, it's based on the material, and so I put all of these devices up against 18 different surfaces as well. Okay, so this is a big table. What we're looking at here are performance using each of the individual sensors and then combinations of, for example, accelerometer and light and proximity, accelerometer and the multispectral sensor, the capacitive sensor, combinations of 3, and then combinations of all 4 at the end. Right, and so what we see is that there are certainly there's some better performance compared to in the wild model. We don't know for sure that that's because we added the sensors. It could also be because it was in a more controlled setting. But this looks promising, right? So if you were going to, for example, try and figure out whether or not a phone was enclosed and you had access to the accelerometer and the light proximity sensor, you could do a pretty good job. I wouldn't say it's going to be exactly 100%, but right, it's pretty promising we can do. And I think this is, a lot of what is going on sort of things that are out in the wild today. Yeah.
That's a biz question. Why did you bolt those randomly?
Yeah, so they're not random. They are the max for each row. Although I understand that there's not a key that would actually indicate that to you, so I'm glad you asked. Yeah. Okay, so zoom back out for a second. Think about what that process looks like. The process that I introduced you to before. We collected a bunch of low-level sensor data. We collected a bunch of ground truth data. We did this sort of infer phone placement step. And this is an outline here because we didn't build any of the things on top of it, right? This is not really good enough that you'd want to use this pipeline that we came up with to actually do something in the real world. We're testing ideas, right? And so all of that I just talked about in brief summary, and I could go into much more detail about, was like that for one specific example. And now that we've done that, let's talk about another one. So the idea of this project is thinking about personal data at a little bit of a higher level, thinking about social relationships and trying to characterize different social relationships using smartphones. That says friendship if you're trying to read that. It's actually the neighborhood I lived in grad school, and it felt especially appropriate on this slide. Okay, so the idea is that basically technology doesn't know anything about my relationships with the people around me. So it knows that there's a me, and it knows that there's an everyone else, and maybe you could argue that today it's a little bit more nuanced than that, but roughly it treats everyone the same. And in reality, we know that our personal networks are super complicated. There's a lot of stuff going on. So there are people that are in your family, you have work colleagues, you have people from sort of social interactions, people that you live near, right? So, and also overlap between these things, right? So it's super messy. And you could imagine that it would be useful for your technology to have a sense of this when it's showing you perhaps notifications for one person versus a different person. And in addition, obviously, there are people that I'm closer to, perhaps in all of those circles, maybe not in all of them, and there are people who are less close. Right, so we know this anecdotally. When I tell you that, it makes sense, but also there is research, there's literature backing that up, right? So there are sort of concentric layers of closeness, people that are considered your support group, your sympathy group, and some more of a regional grouping. It goes back down to like the size of your brain, effectively, right? This is like a pretty well-studied phenomenon. And so social scientists refer to this concept as tie strength or closeness. Strictly speaking, they are different things. I'm going to talk about them here interchangeably, and it's fine for our purposes. Okay, so tie strength is also a useful abstraction. So there's work that shows that people are likely to get jobs from people at a certain level of tie strength from them. Getting social support in situations, right? I mentioned depression before, so if you're thinking about getting social support for mental health, you can recommend sort of the right person, privacy and sharing settings. I wrote a paper on that. That's why that's there. Sorting lists of contacts, right? So you can imagine some reasons this is useful. So the goal here is to infer tie strength with a number of a user's contacts and using call logs, text message logs, and the contact list from their phone, and then some ground truth that a user, a participant in our study would provide in order to do that inference. So we had 40 participants. They each answered questions about 70 of their friends, and we picked these friends in part knowing that some people were likely to be close and not likely to be close, so we asked them to specifically name some people that they considered especially close. There was no problem in biasing people here. Their answers were not the most interesting thing to us. That was just the training data, right? The real question is, can we train a model based on the communication logs to help infer this information? All right, came up with a bunch of features. They fall across some important social science boundaries, right? So this is, again, if we're coming back to this interdisciplinary thing, right? You really do have to draw on literature from different fields when you're doing this. And for example, to make sure that the features that you're coming up with match things that actually mean something in the real world. Okay, and then we separated participants' contacts based on answers from these 4 tie-strength questions into strong ties. There are 4 top contacts, medium ties, the next 15, and then weak ties is the remaining. And again, similar to the phone proprioception example, we did some combining of the classes. So we did a 3 class that are the classes that I just described. We did strong versus medium and weak, so trying to separate out strong ties, and then a strong and medium versus weak, so trying to separate out weak ties. And basically what happened was, it was fine. I should say that if you're not familiar with it, the kappa score is accounting for chance, right? And so because, for example, the very strong category, there are very few examples of the very close contacts. This percent correct is pretty misleading, right? And actually, the performance, that's a way more fair metric because you have a particularly small class at the very strong level. Okay, so those are not great. Those percentages are not great, and I wanted to know why, because actually at this point in my research career, I was pretty confident that that was going to work. I spent a lot of time building up to it. I was super duper disappointed. I ran the numbers 10 times, they didn't change. And so the question is why? So I did phone interviews with 7 participants afterwards to ask them about some of their misclassified contacts. And in retrospect, these things are like pretty straightforward. And I realize that now people use phones even less than they did then, and phone usage in general goes down because why would you talk to someone when you can just text them? But we had text too, right? And so actually what we found is that there are a bunch of different explanations for why you would consider somebody close but not have communication behavior on your phone that would demonstrate it. So some of those are kind of intuitive, like you're using other communication channels. So if you're using instant messenger, we didn't capture that. So, oh well. Right? There are other things like in-person communication, right? I live with my partner, I see her every day, we commute to and from work together. I do still interact with her digitally, but not as much as you might expect, given, right, because we see each other so much. And this is true actually across a lot of examples that are not just me, myself. Right, so people feel close to people from a different life stage, from a previous life stage. So for example, my best man, I talk to maybe once a month, sometimes less than that. Still consider him one of my closest friends, but it's from a different stage of life. And there are some interesting things about family being close regardless of any sort of interaction at all. So there was, in fact, one participant who would always hang up, not accept calls from her grandmother. And she still labeled her grandmother as very close. And yeah, right? So, and we weren't giving anybody any sort of, here's how you define this relationship because we didn't want to bias the model. But what we found was that she did consider her very close, but also did not want to talk to her on the phone. And it wasn't even that she saw her in person that much. It was just that, yes, I'm very close with her and I just don't pick up the phone. Yeah, right? I laughed at that too. So, okay, again, this looks pretty similar. It's just shifted one to the left, right? So we're collecting this communication data, we're collecting that ground truth, we're doing this inference, and we still aren't even doing this because, again, it's pretty hard for me to deploy this model, right? A lot of this stuff I developed ad hoc, it was all experimental. The models were fine, but not great, so I guess that's done, right? What are you gonna do? So, those are 2 examples from sort of a while ago. This is some more recent work that we've done. Has anybody seen this? This sort of was in the news a couple weeks ago, so you might have gotten a glimpse of it. So Jimmy is a PhD student here in the department, had this paper, and And the idea is basically thinking about advancing how people interact with their sort of personalized local air quality. Right, so you can read the headlines. I'm not going to read them all out to you. I think everyone knows pollution sucks. It's all around us. It's going to kill us earlier than we would otherwise have died. All of the bad stuff, right? So what we know, though, is that indoor, right, so people spend a huge amount of their time indoors. And indoor air quality is not uniform, and it doesn't necessarily correspond to the air quality outside. There's a correlation, of course, because when you open the door, bad air can come in, and if bad air gets trapped inside and you don't have the right stuff on, then it might stay there even after it's nice outside. Also, there are sources inside that can cause poor air quality, and the problem is that all of this is mostly invisible unless it becomes really bad. You can't actually see it just with your own eyes. And so our participants in this study, at least one person in the family had asthma, and the problem in this case is that doctors have to give these sort of one-size-fits-all recommendations. So basically, like, I'm a physician, and I'm telling you, like, probably the air quality in your house is better than the air quality outside, knowing nothing about where you live, or if you live next to a freeway, or if you live in the woods in the middle of nowhere, right? And so I'm gonna just tell you, like, keep your windows and doors closed as much as possible because you want to keep the bad air out and the good air in. Things like that, right, are the types of recommendations that physicians have to make because they don't have enough data to give you any fine-grained stuff. And what choice do you have? If you get that recommendation, you're going to listen to it, right? So what we did is we deployed multiple air quality monitors to these 6 families and also gave them the ability to annotate their data either using a tablet, which has this visualization on it, using a Google Home so they could verbally say, hey Google, I'm cooking a steak right now, or text messages. So we would send them a text message with a spike, and when a spike occurred and say, hey, we detected this spike, do you have any idea what caused it? And they could respond with some labels. They would say, I was cleaning, right? And then that label sticks with that data, and they can go back and look at it later when they look at the tablet. And also we have it, right, as researchers, we have access to it. So I'll give you the short version is that people learn things and change their behavior based on the information that we gave them, which was kind of cool to see. I'll give you one example now, and then I'll give you one example when I show you an example of the visualization in a minute. So the one example I'll give you now is that we had one participant who had been cooking with olive oil, and she noticed these spikes. And so this became a mission for her. She wanted to figure out, could she do something to reduce the spikes with her olive oil? So now it's a self-experiment. So, she tried cooking some different things. Ultimately, what she found completely on her own was that cooking with avocado oil resulted, there was a spike because when you're cooking and there's stuff going into the air, these particle sensors are going to pick it up. But the spikes were lower. The PM 2.5 particles, there were fewer of them in the air. And so now she cooks primarily with avocado oil. So does that mean you should all go home and stop cooking with olive oil and start cooking with avocado oil? No, that's not the takeaway here. But in her particular case, her son has a particular type of asthma. It's called asymptomatic asthma. And so when his airway starts to constrict, there are no sort of outward symptoms, right? And he doesn't even necessarily recognize that it's happening. And it's not good. It causes scarring and other health issues in the future. And so this is especially important to her. Anything she can do to reduce the potential risk indoors is something she's going to do. Right, so that's one example. I'll give you another example here in a second. So this is an example, again, where we automatically collected this air quality sensor data. We got these manually provided data annotations from our participants. There's no inference here, right? This is a visualization. So we're going to come back to this in a second. But this visualization process is what led to the data being useful, right? So they were actually able to enact changes in their lives. Okay, so now that we've seen these examples, I want to sort of zoom back out and return to this vision of personal data somehow fueling that future. And the point I want to make is that this is a really, really, really long road. Goes off in the distance quite a ways there. And so to help illustrate that a little bit more, I want to introduce this example query. So I just went to Singapore for a conference, and a totally reasonable question, especially if I had been to Singapore before that, would have been, who did I call and text last time I was in Singapore? Because there's like a high likelihood that maybe I would want to be communicating with those people again. Right? And if there's a lot of them, then you might want that sorted by how close you are to those people, right? Because that's sort of a suggestion of the people that you're more likely to want to talk with. Okay, so there's the query. It's pretty complex, right? So it requires a query on your location history, so visits to Singapore, and it may be more than one. Joined through the date ranges of those visits. To the call logs, who did I call in those days or during those times that I was there, and text message logs, so who did I text on that day, sorted by this inference that's closeness, and that inference comes from a whole bunch of that data again, right? So think about that whole other chain of queries that comes to making that inference. So that's a lot. That's it sounds really simple when you say it up at the top, and then you break it down, and you're like, okay, well, that would take me a long time to actually implement. Right, and so there are a bunch of challenges that we identified that sort of lead into this. I'm not going to talk about all of them, but I do want to talk about a couple, specifically those three. So linking together different types. So if you're going to do this query, you have to link together this location history and the call logs and text message logs and do this sort of thing with data that is not stored together already and maybe stored in different formats and wasn't necessarily intended to do this to perform this way. Right? And also, in some ways databases are made to do this sort of thing, but databases are really bad for things like joins across dates and time ranges. Okay, so another thing here is reusing inference models is another big challenge. So I had the closeness model that I presented to you a while ago, but like I said, it was not especially great, and I didn't ship it out. And so, I would want to reuse that model, and actually a lot of people in the world might want to reuse that model, but instead, today you have to sort of go and reinvent the wheel if you want to leverage that closeness model. Okay, and the other thing, this should be pretty terrifying to you, is that you need to access, you get access to way more data than you need if you want to do this query today. So I get access to all of the location history, not just visits to Singapore, but everything. I get access to all of the call logs and all of the text message logs, right? This is a huge amount of potentially sensitive data. And so that, again, feels like a really massive problem if you're letting developers do this sort of at large. Right? Even when, you ever get one of those text messages that's like, here's a verification code for, signing into some application. And so we need access to your text messages because we want to verify that that text message came in, right? So they ask for blanket access to your text messages because that's all they can get access to. Now they have access to everything. You have no idea what they're doing with it. Okay. So what can we do about this? So I made a sort of prototype system called Phenom, and the idea here is that it's a proof of concept that sort of demonstrates the possibility of some more advanced personal data ecosystem. And so it's all sort of centered around this semantic data store, and the idea is that you can link together data coming from multiple different sources. Once you insert it into this data store, it does a bunch of sort of automatic linking stuff, and stuff is sort of bridged together, so it then becomes much easier to do that query that I just mentioned. And so the data comes in from these data providers, so it's basically an adapter from some external format to the internal format of the system. It inserts into the data store, there's this idea of bots. I call them bots. The idea here is that they're going to process the data that's held within the semantic data store, and for example, doing inferences like the closeness or tie strength inference that I was talking about a minute ago. Also, maybe some other like maintenance or housekeeping sorts of tasks. And then, of course, there's an API, a unified API for querying all of that data through a single source. And so that's the system, and it makes this query a lot easier, right? So now, this is possible because the data is linked together through this semantic data store. The bots support this inference model for tie strength, and so once that's in the system once, you just don't have to do anything with it again. The nice thing about making a bot is that if you make some inference using the external API, bots also have access to that exact same API, so you can just take any inference that you made outside of Phenom and submit it, and now it's sort of reusable for everyone else inside. Right? And then the only data that's accessed ultimately, because you can do all this querying internally, the only data that comes out of the system is the data that answers the question that was asked. Okay, so this is a long road, and it's actually a really long road, right? So that's the same picture, but just zoomed out a lot more, right? So I don't know, I like showing off Utah in my talks. So I'll say that we're making progress, right? So we're like making a couple of steps down that really long road. And I think a lot of really interesting questions remain around privacy and how do we give people sort of meaningful control over that data. Thinking about what it's like to be a developer working with this data. So even something like testing your application and not knowing who it is that might be using it and what sorts of data that they have can be really difficult to test your application in those conditions. Personal data-driven applications, right? I think there's a lot of interesting potential there. Economic models, right? So we talked a little bit about that. I think there are a lot of questions about what does this look like from a company perspective. And again, what does it even mean to own your data? Okay, so I promised, and I will make good on my promise to get to some Viz stuff. This, I was hoping it sort of looked a little bit like a bar chart or some sort of a graph. It's actually just a reflection from a pond, but I like to take pictures. Okay, so I want to give you a couple of examples of visualizing personal data and the sort of interesting things that can come out of that. So this was something that a student showed me when I was still at Carnegie Mellon a couple of years ago. He visualized the use of honorifics, so more formal language, or non-honorifics, so less formal language, between himself and like a TA or like a research mentor, someone that he was working with in a sort of formal capacity. And so what you can see here is that it's sort of like the start of the project here, not very much communication. As the project sort of comes online and they're in the middle of it, there's a lot of communication and it's all mostly pretty formal. And then as the project is sort of winding down, there's less and it's still like mostly formal. And then summer hits and so you're on a vacation, you come back from vacation and the project is not happening anymore, but they're still conversing. And you can see the language go from this more formal language to this less formal, sort of more friendly language, right? So this is actually, like you can see the friendship unfolding here. And, it's one pretty bad example, right? It's not super high fidelity. There's a lot more sources you could look at to see that, but it's kind of cool to think about seeing a concrete representation of what that looks like. Right, and the other thing that I think is really interesting about this is I did not see this in the data when the student showed it to me. I saw this in the data when the student told me the story because they had lived this. They knew what the explanation was, right? But I can't just look at that graph and tell you what it means, right? I would need so much additional context in order to figure that out on my own, right? So there's a really important component of people looking at and thinking about their own data, right, when you're trying to make sense out of these things. And I think that's an important theme and it comes through a lot of different examples that I could give you. So this is an example from my own recent past. So I've been experimenting with some smart home stuff in my spare time, sort of trying to bridge research and fun time at home, which is a great way of trying to get a little bit more research done. And so, I instrumented my house with some of these smart home sensors, and it's kind of fun to see, what shows up in the data when you just mess around with things a little bit, right? So I came home, tried not to run the AC when I was out during the day. I came home and I turned it on, or actually I wanted to turn it on, but I realized, hey, it was actually pretty cool outside. The wind was blowing, so I opened the screen door, or the sliding door. The temperature dropped really dramatically, really quickly. Awesome. But then it started raining. Didn't want rain in the house, so I closed it. You can see it rebound, right? So this is the house has a thermal mass. It retains heat, and so when you close the door, it doesn't just stay at that lower temperature. The walls retained the heat, and so it warmed the house back up. And now the air conditioner is back on, and it sort of starts to fall over time. So again, another one of these examples where this means nothing to anyone except for me, and probably you are bored by looking at this, but somehow this is kind of cool to me. It captures something that I saw happen in the real world. Okay, I promise one more example from the air quality study. We go to for another 5 minutes-ish, right? I'm not holding you all. Okay, good. Right. So this is another example from the air quality study. So what we're seeing here is one of the particle sensors, one of the air quality monitors for one of our participants. And you can, again, see some very interesting routine coming out of this data that maybe you wouldn't have even realized. You can see routine, human behaviors in the air quality data. So you can see they're up and they're getting ready for bed, and that bedtime routine causes sort of fluctuations. They're asleep, and you can see it stays at a pretty low level here. They wake up and they do their morning routine, showering and cleaning and whatever, getting ready to go. And then it's sort of you can see it decay right before then they start to vacuum, right? So our primary participant told this really great story, actually, about how they have a friend who also suffers from asthma and allergies. And this friend always takes Benadryl before they come over. And that's because, they have dogs, and there's, this friend is especially allergic, and so just to be comfortable, she takes medicine. And the participant always used to vacuum, to say, okay, well, I'm gonna also do my part. I wanna clean up the house before the friend comes over, because I don't want them to, be subject to any more allergens or, dust or whatever than they need to be. And with the system deployed in their house, they were able to see that actually when I vacuum, it causes everything to get stirred up, and then it stays in the air for a while, right? It doesn't disappear immediately. The decay sort of takes a little while to go down. And so that participant saw this in the visualization and was able to actually change her behavior so she would clean up longer before the friend would come over. The stuff settles, and this friend comes over one time, forgot to take her medicine. Short story is she was able to stay and not have to go back and take her medicine because, as it turned out, this made a huge difference in the comfort of this friend and their reaction to being in that space. And so again, looking at the sort of labeled version of this data gave this participant the ability to reason about something, to change her behavior, and to sort of leverage that into this sort of new insight, right, that sort of changed some social interactions and some aspects of her life. Okay, so I'm going to wrap up here. I hope that what I've done at this point is to make a broader case that there is an important space for visualization in the context of personal data to sort of play part of the bridging gap between where we are today with this sort of really diverse, fragmented state of personal data and that sort of maybe awesome, maybe scary future of hyper-personalized experiences, right? And I think visualization can sort of help us to understand what really is contained within the data and what are some possible steps forward between where we are today and where we might be in the future. So with that, I'll just mention that I'm always recruiting interested, engaged students who want to work on things that excite us both. You should reach out to me. And yeah, that's what I've got to say. So thanks for paying attention. So I'll stick around for a couple of minutes. I'm actually teaching another class in not very long from now, so I'll stick around for a couple of minutes. And I'm also here like all the time if anyone wants to speak with me more. But I'm not going to hold you all for questions or anything. Just